Hey guys, Mr. Palmer back with our final part, part 6 of this momentum review calculation. Again, you should really try these two problems on your own first, and then come back and watch my solution. Rewatch it if you get stuck, what have you. Okay, so I'm going to go through this one. This one involves um, a astronaut lost from the space shuttle who's floating around. This is an explosion problem because we have two objects that are together. We have an astronaut together with her tool belt. And she's going to try to get back to the ship. So in space, she knows that conservation of momentum, right? Momentum's going to be conserved. If she wants to go in one direction, she's going to have to send this tool belt in the opposite direction. So let's think about that in terms of momentum. So if this is my astronaut, this is her mass. She's going to be object 1 plus her tool belt, which would be object 2. The two masses added together times her velocity before the collision. Well, what do we know about that? We know before the collision she's not moving, so we're going to call that 0. So relative to the ship, she's stuck some distance away and she wants to move towards it. She doesn't have any momentum. Well, what she's going to do is she is going to know that after the collision, if she sends an object hurtling away from her, that she will go in the other direction because the momentum is going to be conserved. If before the collision she had 0 total momentum and she wants to go in one direction, we know that these two are going to be equal and opposite. So that means her momentum, if she throws this tool belt, is going to be equal and opposite the momentum of the tool belt, M2V2. So if we put in her information, it tells us that she is 65 kilograms for her mass. We don't know what her velocity is going to be. And she's going to move towards the ship. And, well, it says the tool belt, it's 3.5 kilograms. That's its mass. And she can throw it away at a speed of 3.4 meters per second. Right? I don't need the units, I'll leave that out. Okay? So the momentum of the tool belt, we multiply that together, divide both sides by her mass, which is the 65. That gives us a velocity of negative 0.183 meters per second. Now what does that mean? Negative means it's going the opposite direction as the tool belt because that was a negative velocity. Okay? So that's where that solution comes from in this one. And we're going to use that for any kind of problem involving an explosion. So let's take a look at number 10. In this case, it's not a 0 total momentum. In this case, the rocket involved in this one, in number 10, has some momentum. Draw a little rocket here. Before and after the collision, it's never 0. So we have this rocket, it's 150 meters per second is its velocity. And we're told that it has a mass of 150 kilograms. Okay, it says it's traveling to the east, that's why I have it moving to the right. It's going to break apart into two pieces. Right? One piece, we'll assume is the back, and one piece is the front. We can call piece 1 and 2. Okay, so while traveling through mass times velocity of this one, momentum before, it breaks apart and turns into two pieces. One is going to have a mass of 100 kilograms, and one is going to have a mass of 50 kilograms. And so M1V1 plus M2V2 will be equal to our mass, or rather our momentum before. Alright, so let's put in our numbers. 150 kilograms times 150 meters per second. It explodes. There's a 50 kilogram piece moving 200 meters per second to the east. So our 50 kilogram piece is traveling 200 meters to the east. That's positive 200. It was to the east over here. That's a positive 150. And we want to know the speed, or velocity rather, of the 100 kilogram piece, so that we're only going to have one unknown variable here. Alright, so 150 times 150, we're going to get a number over here on the left. That is 22,500. That's going to give us 10,000 over here, plus 100 times V1. We're going to subtract the 10,000 from both sides. It's going to give us 12,500 equals 100 times v1. And that's going to tell us that this 100 kilogram piece has a velocity of 125 meters per second. That is going to be positive, so it is also to the east. You can just leave it as a positive, you could write it as east, but you need to provide a direction. Don't forget to ask me any questions, try these on your own, let me know how you do.